Hey, it's Mrs. Weethy here for lesson 9, and it's all about Lewis structures. Yay! I bet you can't wait. So, what is a Lewis structure? Well, it consists of an electron distribution in a compound that represents the molecular structure of the compound. And it's covalent compound. We generally draw Lewis structures for covalent compounds. So we have several rules for writing Lewis structures, and the first one is to determine the number of valence electrons that is available in the molecule. Now the molecule we have here, carbon tetrachloride, the molecule represents the exact number of atoms of each element that you have in the compound. So we want to figure out what are the total number of valence electrons that are available for these atoms that are making up this compound. So here's what we do. We take the number of carbon atoms, which is 1. One carbon atom has 4 valence electrons, and then we're going to add that to the number of valence electrons in the chlorines. Well, we have 4 chlorines, each one having 7 valence electrons. That gives us 28, and add those up and we have a total of 32 electrons that are available amongst the atoms in this compound. The next thing is to determine the central atom, and the central atom is the least electronegative atom, or the most positive. So how do you figure that out? Well, according to our periodic properties, electronegativity gets higher as you go across the period. So as you go across the period, those atoms are becoming more and more negative. As you go down a group, they become more and more positive. Their electronegativity is going to decrease. But here are 2 other things that we can consider. Hydrogen and the halogens will never be center atoms because they only form one bond. Carbon, on the other hand, will always be a center atom because it can form 4 bonds. And if you consider hydrogen, halogens, and carbon, you usually can just figure out then what your center atom is going to be. So in our molecule, we have carbon and chlorine, and because chlorine is a halogen, it can't be in the center, so carbon will be our center atom. Our third step is to write what is called the skeletal structure. So we are going to place the carbon, our center atom, we're going to draw it into the center, and then we're going to bond each one of the chlorines to that center atom with a pair of electrons. So let's do that. We have carbon, and then to the carbon we're going to bond each one of those chlorines with a pair of electrons. So this is what is called our skeletal structure. Our next step now is we want to add lone pair of electrons around every atom, so every atom has a complete octet except for hydrogen, which will only ever have 2 electrons, or a stable duet. So each one of these chlorines needs 3 pair or 6 electrons to complete its octet. So we'll just get those drawn in there. And then if we take a look at this, the red electrons are what are being shared between the carbon and the chlorines, and so they belong to each. And if we see around the carbon we have 8 electrons, and then around each one of the chlorines we have 8 electrons, so they have a complete octet. Now, these electrons around the outside of the chlorines, these are called the lone pair. The lone pair are valence electrons, but they are not involved in the bond. And then the red electrons that I have here, these are called, and we have multiple names for them, bond pair, shared pair, covalent pair. Those are the electrons that are involved in the bond. The next step is to count all the electrons that were used in this structure. The number of electrons used has to be equal to the number that were available that we determined in step number 1. So we used 32 electrons. If we counted all these up, we'd find we had 30 electrons used, and in step number 1 we figured that there were 32 electrons available. When those 2 numbers are equal, that tells us that we have drawn a correct Lewis structure. The next thing that we're going to do is we're going to replace the bond pair electrons with the dash to represent the covalent bond. So every dash that we have here represents a pair of electrons, or 2 electrons for that bond pair. This is what we call the structural formula. So the Lewis structure is all with the dots. The structural formula is where we replace the bond pair with the dash. So let's practice another one. We have water. We have 2 valence electrons between the hydrogens and 6 valence electrons with the oxygen. That gives us 8 electrons that are available. Hydrogen can't be the center atom, so we're going to put oxygen in the center, bond the 2 hydrogens to the oxygen. Oxygen only has 4 valence electrons around it, so we need to add in 2 more pair of electrons. So now we have 8 electrons used compared to the 8 electrons that are available. Rewrite this as the structural formula, and there we have the molecular structure for water. One more. We have ammonia, NH3. We have 5 electrons for nitrogen. We're going to add that to the 3 electrons, 1 each for the 3 hydrogens. That gives us 8 electrons total. Hydrogen can't be a center, so we're going to put nitrogen in the center. Bond the 3 hydrogens to the nitrogen with a bond pair. Hydrogen only has 6 valence electrons around it, so we are going to add in our 4th pair, or the 2 electrons, to give us a complete octet. We're going to replace the bond pair with a dash, and that will give us a structural formula, and the number of electrons we used is 8 compared to the number that is available. Okay, so that is how we draw basic Lewis structures. There's 2 that I want you to practice before class, pH2Cl and CH2Br2. So, this is Mrs. Lethe. Until next time, signing out for now. Goodbye.